2 ampere current is reaching at A. 2 ampere current is reaching at A. Now I told you there are two branches. One is ACD branch, one another is AB branch directly. Both ACD branch and AB branch are having same resistance. So as it comes down, its velocity will increase. Now go to the explanation part quickly. We have, velocity of a body coming down is given by current is in clockwise direction. So somebody looking from O1 will find that there is a south pole here. Somebody looking on C1 from the center O2, current is in anti-clockwise direction. We come to the next question. This question is coming from Electromagnetic Induction and related paper. Okay, come on. Now, yes, there is a circuit given to you. Circuit contains inductor, capacitor, no inductor is there. Now, here source of EMF, there is a network. We have a clear explanation. Let's go to this step. Now, here source is a DC source. And when a DC source is introduced in the network, inductor behaves as a what? Perfect conductor. At steady state we're talking about is exactly steady state, inductor behaves exactly as a what? Connecting wire. It doesn't offer any resistance. It is open, what we can say, not open circuit, as a short circuit because no resistance, zero resistance, correct. But as far as capacitor is considered, capacitor offers infinite resistance. Or in other words, at steady state in a branch, a capacitor is coming, capacitor will not permit any current and there will be no current passing through the branch in which who is coming, capacitor is coming. No current passing through the branch in which a capacitor is coming. Now tell me, look, current will pass through this, current will be distributed. So these two 8 ohms are in parallel, effective will be 4, 4 and 4 will be in series, that will be 8. So this section between these sections I can say, if I say A, B, C, D. Between ACD, no current passing through the branch D, I can say. So these two will be in parallel, 4 ohms, 4 and 4 are what? So in the ACD branch, effective resistance is 8 ohms. Then directly AB branch, directly 8 ohms. So what is effective resistance? 8 and 8 parallel. So net effective resistance of the combination will be 8 and 8 parallel, 4 plus 1, that is 5 ohm resistance. The whole network of resistance, effective resistance will be what? 5 ohms. Therefore, main current, I say main current will be EMF is 10, effective resistance is what? 2 ampere current. 2 ampere current is reaching at A. 2 ampere current is reaching at A. Now I told you there are two branches. One is ACD branch, one another is AB branch directly. Both ACD branch and AB branch are having same resistance. So what will be happening? Current will be equally how much entering at A? 2 ampere. So 1 ampere will be passing through this and 1 ampere will be passing through this branch. So tell me, the current coming through the ACD branch will also pass through the ammeter. So current through ammeter will be 1 ampere. So your answer is 1 ampere, option 1. We go to the next question. Look, a long solenoid 100 centimeter long of radius 2 centimeter having 500 turns carries a current 100 omega is 100 circular conducting loop of radius 1 centimeter coaxially glided through the solenoid at a speed of 1 meter centimeter. The RMS current in the loop when the coil is inserted 10 centimeter inside it is alpha by root 2 microampere. We have to find the value of alpha. We go to the explanation. Tell me, magnetic field inside solenoid, you know B0 is equal to B0 Ni, correct? That is coming to be 500, 5,000, because number of turns you have to calculate, number of turns per N will be is equal to number of turns per unit length. How many turns you are having? 500. Per how many length? 1 meter. So this is 500. 500 by 1, 500. N 500, 10 sin omega t. That is 5,000 mu0 sin omega t. Now, flux linked will be, in the coil will be 5,000 sin omega t into area, pi into 0.01, we got it. 0.5 pi mu0 sin omega t. Then induced EMF is minus d sin omega t minus 5 mu0 omega cos omega t. Got it? Differentiating simple. It will be multiplied with omega, isn't it? It will become cos omega t. And peak value of amplitude of EMF is what? Mu0 pi, that is 0.5 pi, mu0's value is substituted into what? Into omega. Omega is coming to be, which omega's value 1000. Got it? So this is coming to be 19.7 into 10 to the power of minus 4 volt. Then current, RMS value of current will be, RMS value of voltage will be E0 by root 2. Then RMS current will be ERMS divided by resistance. Resistance is given in the last 10 ohms. This is 19.C 10 to the power of minus 3 into 10 root 2. That is coming to be 197 by root 2 microampere. And it is given that the RMS value of current is given by alpha divided by root 2 microampere. Alpha divided by root 2 microampere. And here we got 197 by root 2 microampere. So who is in place of that? Alpha 197. In your question option, I will go to the question to make it clear. Yes, 197 is the B option. Correct. Now coming to the next question. Now, circular loop of radius and place and uniform magnetic field directed perpendicular to the loop. Loop is converted into a square loop. EMF induced. Tell me, we can go to the explanations. Again, it is everything is clear in black and white. Now tell me here, what is the reason for the change of flux? The reason for change of flux is change of area, because flux linked is given by BA cos theta. Flux may change, either B changes or A changes or orientation changes. Here area is changing. What is the reason for area change? Reason for area change is it changes from a circular loop to a square loop. Now radius is given to be how much? 7 centimeter means 0.07. Area, initial area is given by pi r square 22 by 7 into 0.07. That comes to be, when you work it out, 0.0154 in meter square. Okay. Now when you come into the square loop, first you have to get the side of the square. The circumference of a circle, circular loop of perimeter 2 pi r is changed into a square loop of perimeter 4a. Circular loop of perimeter 2 pi r changed into a square loop of perimeter 4a. So what we have done, we equated it to find that is A is equal to 2 pi r. 2 pi r is coming to be 0.44 divided by 4, that is 0.11 meter. We got the side. Then area is equal to A square, 0.1 square, that is in meter square, it is coming to be 0.01 into 2 meter square. Then it was 0.0154 meter squared. Now it is 0.0121 meter squared. So there is a change in magnetic flux. What is that? B into change in area. B, we got it as given to be how much? 0.2. So 0.2 into change of area. Change of area is coming to be 0.0033. That is 0.0066 Weber. Then induced EMF is change of flux by time, 0.00066 by 0.5. That is 0.00132 volt. That is coming to be 1.32 millivolt. 1.3. That is, induced EMF is given by 1.32 millivolt. Now go to the options. Options, no, we have to fill up the blanks. Here in the bracket, we have to write how many? 132 millivolt. 132 millivolt. Okay. Yes, 132 millivolt is there. Okay. Yes. Next question. Pendulum is made up of mass 10 gram and metallic wire of length 10 centimeter, suspended vertically in uniform magnetic field. Magnetic field direction is perpendicular to the plane of the loop. Oscillations of the pendulum. Pendulum is released from an angle. So I'll draw a diagram here. Better here. Yes. This is the initial position of the pendulum, making an angle 60 degree. The pendulum will keep a circular path, and this is equilibrium position. At equilibrium position, when it reaches its tangential speed is maximum. Tangential speed is maximum. Okay. Then when you get tangential speed, okay. Now let us calculate the tangential speed. How you are going to calculate the tangential speed? From this diagram, we can find that the pendulum has come down through a depth h. And we have a ready-made formula for the depth h came down is, here it is given, length of the pendulum in 1 minus cos 60, that is 1 minus 0.5, that is coming to be. This is the depth it came down. And here it has got potential energy, is converted into kinetic energy, velocity maximum at the equilibrium position now is root 2gh, that is coming to be 1 meter per second. Okay, so when pendulum bob reaches the equilibrium position, many occasions we are doing this conversion. Pendulum's height is L into 1 minus cos theta. Height, it has been converted into kinetic energy, that is velocity is given by 1 meter per second. Now, you know, velocity of the pendulum string at different points will be what? Different. Maximum at the bottommost point and when it reaches equilibrium position. But you know, at any point on the pendulum string, what will be happening? Angular speed is same. Angular speed is same. So, angular speed at the bottom is same as that of angular speed everywhere. Angular speed, how we calculate? Maximum by length, 1 by 0.1, 10 radians per second. Because length was 0.1, pendulum's length is given to be how much? 10 centimeter means 0.1. And velocity, we got it as 10, therefore 1 meter per second, therefore we got it as 10 radians per second. Now, you know, as it moving, there is a magnetic field getting into the plane of the magnetic field. In the case of a rod rotating about one end, that is magnetic field, magnetic EMF induced is given by half B omega L square, and half into B is given to be how much? 2 Tesla, omega we got 10, L square is 0.01, 2 get cancelled, this is coming to be 0.1 volt or 100 millivolt. So, in the fill up the blanks, answer here it is, fill up the, yes, option is, it is coming to be how much? We got 100 millivolt. So, answer is coming to be, what you have to calculate when it reaches induced EMF after distance of, okay, options, let me check the question paper. This is correct. We have to fill up the blanks only, no options given. This is coming to be 100 millivolt, 100 millivolt. That's correct. Next question, this is another question. 20 meter long uniform copper wire is held horizontally, allowed to fall under gravity. Then magnetic field of 0.55 goes perpendicular to the length of the wire. Induced EMF across the wire when it travels a vertical distance. So, as it comes down, its velocity will increase. Now go to the explanation part quickly. We have, you know, velocity of a body coming down is given by root 2gh, that is, it has come down by 200 meter, that is coming to be root of 4000, that is 20 root meter per second. And this is a BLV problem. Induced EMF across the rod is given by what? BLV, B is 0.1 goes 1 goes means 10 to the power of minus 4. So this is coming to be 0.5 into 10 to the power of minus Tesla. Induced EMF is equal to BLV. B is 0.5, 10 to the power of length is how many? Velocity is 20 root 10. Length of the rod is 20. That comes to be 20. When you work it out, this is coming to be 20 into root 10 millivolt. 20 into root 2 millivolt. So this is ordinary. But here it is that as it comes down, speed is increasing, the potential difference across the rod will be increasing. Here it is asked at the moment when it has come down. So we should get velocity at that instant. Your answer is coming according to the question paper is 2, 20 root 2 milli. Yes, we go to the next question. And a conducting circular loop is placed about a diameter at a constant angular speed of 100 radians per second in the magnetic field perpendicular to it. When the loop is rotated through an angle 30 degree from the horizontal position, induced EMF will be. Okay. Then let us go to the question directly. We can go to the question directly. Yes. Come on. You know, flux in the coil rotating, we have to think that how we are rotating the coil. We are rotating the coil like this. I think you can see that, rotating the coil. So there are some occasions the plane of the coil will be perpendicular to it, flux linked will be maximum. Some occasions plane of the coil will be parallel to that, flux linked will be 0. As a result, as you are rotating, the flux linked to the coil will be continuously changing, and this is the case of an AC generator happening. Now, let us equation for the flux at any moment. T is angle turned is coming to be omega t. Therefore, BA cos theta, P omega t. Induced EMF is given by BA omega sin omega t, because cos omega will become omega minus omega t minus get cancelled. Then when it is loop is turned through 30 degree, normal to the plane of the coil will also turn through 30 degree. Here we take in that manner, from initial position it is turned to 30 degree. So other option we don't require it. Then we will be getting what will be the induced EMF, that is B. B is given to be how much? 0.5 Tesla. B is coming to induced EMF is 0.5 Tesla into 22 by 7 R squared into 100 into sine 30. Its value is given to be how much? 15.4 millivolt. This is already given 15.4. So this 15.5, 4 into 10 to the power of minus 3 can equate to 25 into 2277 by R squared. Simplifying, we are getting 550 by 7 R squared. Solving, value of R squared is given to be 196 into 10 to the power of separate root. We'll be getting 196 into 10 to the power of minus 3. Its root will be 14 into 10 to the power of minus 3, or 14 millimeter. Radius will be 14 millimeter. So very direct question, isn't it? Question of AC generator. We can directly use the formula for induced EMF is what? BA n sin omega t. We can also directly use it, BA n sin omega t, isn't it? Okay, then everything is given to you. Next, figure shows contains 3 resistance 9 ohms each, inductors 4 millihenry each. Reading of the ammeter, we have to calculate it. Okay, look again. When circuit is switched on, so we can go to the explanation. So again, you can get the idea. Immediately after circuit is switched on, that is at the instant t. I told you earlier, just after switching on, inductor offers infinite resistance. Just after switching on, inductor current is abruptly increasing in a short interval of time. That causes in very large infinite back EMF. It will offer infinite impedance to the current flow. So just after switching on, no current will pass through the inductor branch. So we can find inductor acts as an open circuit, means no current will be passing through it. It offers infinite resistance. No current flows through that branch. So no current flows through this branch just after switching on. No current will pass through. No current will pass through this branch. So it has become a very simple branch. 9-volt source, ammeter, this 9 ohm resistance, and key switched on in a simple circuit of how much EMF, 9 volt, how much current, how much resistance, 9 ohms, current will be 1 ampere. Just after switching off. Just after switching off. And another possibility is that after very long time, we say steady state is reached. That is not asked, but if it is asked, so what will be happening? Inductor will be acting like a conductor. It will offer no resistance. There will be a 9 ohm resistance here. There will be a 9 ohm resistance here, because after a very long time, this is asked just after switching on. But after a very long time, each inductor will have no role to play. It will conduct current like a conductor. So we will be getting 3 resistances in parallel. 9 ohm, 9 ohm, 9 ohm in parallel. Effective will be 3 ohms. Then current will be 3 ampere. When, if it is asked after a long time, but here it is asked just after switching on. Inductors will offer infinite resistance. Okay, answer is 1 ampere. We go to the next question. Tell me, inductor's coil of 10 to the power of turns 10 millihenry is connected to a source of EMF. Internal resistance of 10 ohms. Energy density in the inductor when the current becomes 1 by E of it. And here, you don't worry about the value of E. Answer is also given in terms of alpha pi into 1 by. You have to calculate the value of, what? E we have to calculate it, isn't it? We have to find the value of that. Okay, come on. Now, we're going to go to the explanation. Look, first of all, it is a DC source. Okay? And we know in the inductor, there will be a magnetic field produced, and magnetic field is given by mu 0 Ni, and energy density is given by B square by 2 mu 0. Okay? B is mu 0. So it will be coming to be, instead of B, I can substitute mu 0 Ni. So mu 0 square, N square, I square, 1 mu 0 in the bottom get cancelled. You are getting what? Energy density we have to calculate is 1 by 2 mu 0 N square, I square. N is number of turns per unit length. How much turns are there? 10 to the power of 4 turns. And length is how much? A coil of 10 to the power of turns, 10 Henry, is connected to DC source. Okay, 10 to the power of 4 turns, isn't it? So, this is coming to be, yes, 10 to the power of 4 turns. A coil with 10 to the power of turns is connected to DC source. So, one thing they are missing, they have to give number of turns per meter. Number of turns per meter should be given. Okay? Yes. So, it will be 10 to the power of 4 per meter. So, we got the value of this. Now, maximum current can flow in a DC source connected to inductor, maximum current means at steady state. At steady state, maximum current who has no role to play, inductor has no role to play. I told you at steady state, inductor will behave like it, resistive part will work. So the maximum current is possible, V by R. Resistance is coming to be how much? 10 ohm. 10 by 10, 1 ampere current. Is it so? And it is told that current has become I by E or maximum by E. That is, I is 1 ampere, 1 by E. So we want to calculate what? The energy density corresponding to current is 1 by E, 1 by E. So what is the formula for it? Half mu 0 value 4 pi 10 to the power of minus 7, number of turns 10 to the power of 4 whole square into 1 by E whole square. This is coming to be 20 pi into 1 by E square. And question is given, this is given to be alpha pi into 1 by E square joule per meter square. Comparing 1 by E square, pi, who is in place of alpha? Alpha is coming to be 20. Alpha is coming to be 20. Okay. So here we don't require the value of B. 10 millihenry field is not required here. Isn't it? Okay. Come on. Because it is told to be inductance coil, we can take it as, it's not specifically mentioned, we can take it as an what coil? Circular coil. We have taken it like that. Now, there is a frame, vertical, smooth, long plane, resistance R, Px is parallel to Qi. These are parallel frames, these are parallel, so it is a rectangular frame, that's the meaning of it. And separation between them is L, and rod of length capital L, L is given to be greater than 5, is made to slide down. Now tell me, when it is sliding down, this is a case of what? BLV problem. BLV problem. And magnetic field, so I'll go to the explanation part, that will be better. That will be, explanation part will be better. Yes. Look, we can find that induced EMF will be BLV. Remember, length of the rod is capital L, but length of the rod within the frame, what did you take? That is small L only. That is the separation between rods PX and PY. So note that length of the rod is given to be capital L, but whole L is not in the region of magnetic field, so it will be only small length, so BVL, correct? Now current through, because it's a conducting wire, current is given by BVL by R. And you know that when a current is passing, there will be a magnetic Lorentz force acting given by BAL, that is B square L square V by R. This much force will be acting on the rod. And you know, as it is coming down, who pulls it down? Mg is pulling it down. Mg is pulling it down. So as it comes down, Mg is pulling it down. Then force will be acting in upwards direction. So as it comes down, the force is given by B square L square R, B square L square V by R. B is constant, L is constant, R is constant. But as it comes down, it is coming down and down, speed increases, therefore force will be increasing. Force is acting in upward direction and Mg is pulling it down. So what will be happening? A stage will be reaching, net force on the rod will become zero. Just like we have studied in spherical object is coming down through a viscous liquid. When net force on the spherical object becomes zero, it attains a constant speed, terminal speed. It will maintain a steady speed further. After that, it will not be. Same case happening here. Here it is due to, not due to viscous force. Here it is due to the two forces. One is magnetic force and the other is mg. So what we can write, this b square vl square by r is equal to mg, or v is coming to be mgr divided by b square l square, and according to the question, mgr by b square l square, and that is first option. mgr by b square l square will be the velocity, isn't it? Next question. Look, C1, C2, C3 are closely placed such that they share common axis. C2 is exactly midway between. C1 carries a current I in anti-clockwise direction. C3 carries a current I in the clockwise direction. And induced current C2 will be in clockwise direction. I'm not going to the explanation part. I think it may be there, but that is not, I think, complete or not clear. So it is a better simple way we can explain it. Let me draw the diagram first. Look. So better I use the, so they have common axis. And C1, C3, C2. Instead of mentioning by drawing the clockwise anti, better I write it. Current in, this is midway between point they told. Here it is anti-clockwise. Here it is clockwise. Induced one. This is already having, not induced one. Clockwise. Now, you know, if I looking from this point O, center of the middle one, current is in clockwise direction. So when you look into the coil, there is the clock rule, we say clock rule. When you look into the current is in clockwise direction, that magnetic field is getting into it, that side should be a south pole. And if it is in anti-clockwise direction, if you look into that, current is in anti-clockwise direction, that will be north pole. Okay. Now look, we look from O, this is center of this O, O2. This is O1, this is O3. When you look from O2, better I write suffix. O1, O2. You know, current is in anti-clockwise direction, they told. So that side will be appearing as a north pole using clock rule, because current is in anti-clockwise direction. Now, what is happening? Due to the current, varying current, what will be happening? An induced current is developed in C2. Induced current is in clockwise direction. So, if Q1, if somebody is looking from O1 to the coil C2, current is in what direction? Current is in clockwise direction. So, somebody looking from O1 will find that there is a south pole here. Somebody looking on C1 from the center O2, current is in anti-clockwise direction. The person at O2 will say that that side of the coil facing him will be a north pole. Now it is mentioned that due to the currents, there is an induced EMF, induced current developed in the C2. That current is in clockwise. So somebody looking from O1 into the coil C2, current is in clockwise direction. So he will feel that a south pole. Now go to the other side. Somebody looking from O3, looking into the coil, current is in clockwise, he will feel that is a south pole. Similarly, somebody in O2, looking to the coil C3, current is in clockwise, again he will feel a south pole. So what we find, person at C3 looking at the coil 2, induced current is in clockwise, so he will feel a south pole facing him. Somebody at O2 looking at coil C3, current is in clockwise, he will find a south pole. Now look at the situation. For the persons at O1 and O2, one is north pole, another is south pole, they will be attracting. So, what is the reason for that? C1 will be moving towards C2. Because north pole and south pole, C1 will be moving towards C2. As a result, what will be happening? The induced current is in clockwise direction. Come on. Now, looking here, C3 and C2. For C3 and C2, what do they find that? They find that the current, they are attracting each other. So, it means C3 will be moving towards C2. That causes current in the coil will be acting. They will be repelling each other. So C3 will be moving away from it. They are repelling each other. C3 will be moving because due to the development of induced current in C2, the in between C1 and C2, one side north pole, other side south pole, they will be attracting, moving towards each other. Between C2 and C3, both sides are south pole. What will be happening? That will be attracting, repelling each other. So this will be happening. C1 moves towards C2 and C3 moves away from C2. Next, that be explanation I have avoided. Come on. A conducting circular loop of area 1.3 is placed in a perpendicular magnetic field which varies. Alternating EMF is there. Okay. The resistance of the loop is 100 ohms. Then average thermal energy dissipated in one period. Okay, let us go to the explanation. Explanation is clearly given. Now look, flux developed in the coil. How much? B into A. A is 100 sin omega t. That is sin 100 t. Induced EMF minus d phi by dt. Because it is varying current, varying field, flux is changing. That is minus 100 cos 100 t. Then instantaneous power is given by E squared by R. E squared by R will be 100 squared cos square 100 t divided by R is 100. 100 get cancelled, we are getting 100 cos square 100 t. That is instantaneous power. Then how to get average power? So I'll write that calculation of average power separately. Power instantaneous is given by 100 cos square 100 t. Average power, 100 is a constant, I will take it out. Average of cos square 100 t. In alternating current chapter, NCERT has introduced this idea of average power. If it is a sine function or cos function, averaging or one period will become 0. But cos square term, basically it is integration only, but for easy way of calculation, average power over sine square term will be half. So this will be half. Therefore, 100 into half, that comes to be 50 watts. Isn't it? Then average power is given by 50 watt. Now, time period is 2 pi by omega. Omega is given to be how much? Sine 100 t. Omega is 100. So pi by 5 seconds. And average power into time period will be the heat liberated. I have to calculate average heat liberated. That is average power into Time is 1 period. Average power we got is 50 watts. Average power is coming to be 50 watts. So it will be 50 into time is pi by 50. 50 get cancelled. It is coming to be pi joules. It is coming to be pi joules. So your answer is option 4. Option 4. Okay. Now we go to the last question, I think so. Look, diagram given. A 1 meter long wire AB completes a circuit that's on there is a frame, complete circle. Area of perpendicular to the magnetic field is getting into it. Magnetic field, I will write here is how much? 0.1 Tesla. Then the resistance of the circuit is 2 ohms. Whole network's resistance is coming to be 2 ohms. The force needed to move the rod. Rod is moving with the speed. V of the speed is 1.5 meter per second. Let us go to the explanation. We can easily get it. Options you keep in mind. Options you keep in mind. Yes. Look, tell me, this is the rod moving, BLV problem, induced EMF is BLV and induced current is E by R, that is BLV by R, induced current. We have done it earlier. As a result, there will be a force acting on the rod, pulling it backwards. If you are pulling the rod towards right, there will be a force acting towards the left, and force is given by BIL. I is got it as BLV by R. Force is given to be B square V by L square. We are doing it second or third time. When a rod is moving, force is acting by B square V L square. Now, tell me, look, we are moving with a constant speed. So B is fixed, V is fixed, L is fixed, R is fixed. So it's a constant force will be developed on it. Constant force will be developed on it. Isn't it? Because who is pulling it back? This much force. So we have to, question is asked you, the force needed to, how much force pulling it back? Force pulling it back is B square V L square by R. So in order to maintain the steady speed, what we have to do is that we have to pull the rod with this force equal to B square V L square by R. So we can maintain it, isn't it? If force is more, speed will increase. Force is less, speed will decrease. Okay, now you have to simply substitute B given to be 0.1, B square is V is 1.5, L is 1 meter. Simple calculation. This is coming to be 0.0075 or 7.5 into 10 to the power of minus 3 Tesla. Let us look into the option. This is coming to be third option. Okay. So this is all about. Okay. So we have gone through this method explanation coming on the board, because you are getting clear explanation and we are supporting it. So we can save a lot of time. That's why we have gone for that. Okay, then all the best. Your JEE Mains examinations are approaching. All the best for that. Okay, bye.